All right, so we got 4 problems here today. We're going to do problem 20, region 1, about OC. Region 1 is bound by y equals x cubed, the line x equals 1, the line y equals 0, and they're going to take it about OC, which is the y-axis. All right, 2 ways to do this. The easy method is cylindrical shells. All right, if you're not to that lesson yet, the way we have to do it right now is we're going to take the integral of ay dy because we're going about the y-axis. And it starts at 0 and it goes to 1 for the integral. And we look at this, and you have to catch that this is Ri and Ro. All right? It is a washer. Okay? Now, if I draw the shape, and I'm looking around the desk because I don't see a lot of shapes, Ro is always 1. You guys agree? And Ri in this case is equal to this x distance right here. Okay? So we're going to say that equals x. Well, y equals x cubed. X equals cube root of y. All right? So I'm going to say Ri, because I'm working in dy, all right, that Ri is the cube root of y. All right. So now we're going to go 0 to 1. Put the pi out. Ro squared minus Ri squared, right? dy. This time, pi 0 to 1. And I get 1 squared minus y to the third squared dy. And again, we're getting pretty good at antiderivative. We're taking the integral. So I think you guys could do this part pretty well. All right? I'm going to use my calculator today to do this. All right? All right, so we use our calculator to do the integral to get lazy, and we get that it's 0.4000 pi. And if it was a multiple choice, if you did this longhand, you're going to find the fraction was 2/5 pi. You have to know that this answer from your integral and 2/5. You guys are smart, right? Fraction, decimal, percent. You have to make those transitions. All right? There is another way to do this, okay? If I group all this, all right, I group all this. This was a hard way to do this problem, period. Here's what I want you to catch. 6.3 is cylindrical shells. These problems are under 6.2, but we catch that in this case, we're trying to go about the y-axis up here. So how about this from 6.3? 2 pi x f of x dx. We're doing cylindrical shells, right? And if I do it this way, do you guys agree? We're taking a dx thickness, the thickness of that line, the purple line is dx. The distance of that purple line is x. How tall is that line? It is f of x tall, which is just x cubed. All right? So again, and now we can integrate from 0 to 1. I'll put the 2 pi out. 0 to 1, x times x cubed. And I know this is a really super integral, easy integral, but can we try that on our calculator? And I know you guys got the old one, but I'm going to capture our screen here. Math. All right, first type the equation. And I know this is going to be x to the 4th. I suppose I could write x times x to the 3rd, just if I really want to be lazy, right? And have the calculator do all the work. You guys would type x to the 4th, comma, x, comma, 0, comma, 1. You should get 0.2. You should get 0.2. So again, and I would write use TI-84. All right, use TI-84. So I get 2 pi times 0.2. Everybody, is that 0.4 pi? 0.4 pi again? Sure is. All right, but we just did problem 20 2 ways, and we used our TI calculator to integrate. All right. So now I'm going to do 22, 24, 26 with you guys, all right? But I'm going to give you guys a chance to do them all. All right, and let's put up answers, one after the other. All right, so 22, here's just the answer. You're revolving around BC. You have RI and RO. Again, this is a case where there is a shift over here, all right, for RI, because you have to figure out the distance. You got to look at the picture and make it. You should get 5/14 pi longhand, or if you use your calculator, 0.3571 pi. That is the answer to 22. All right, and there's the steps. And I don't show the integration, but you guys know how to do that. Let's try 24. So problem 24, again, it's a disc, not a washer. It's about OC, so it's about this axis. You reach out here, so you just have a radius r, which is the distance of x, but this time x is equal to y squared when you solve for the curve. And now you just simply input it in. And again, your calculator will do this work. So you input it in, you get 0.2 pi or 1/5 pi. Last one, number 26. You see the region here? Again, you're going about a line that is horizontal, so it is dx thickness. I marked right here the r, okay? So it is 1 minus the y distance, because over here, guys, r plus y at this time had to be 1. If I was going about y equals 2, it would be r plus y equals 2. All right? Again, that number set. When you solve for that, r equals 1 minus y, which I wrote over here. Then we know y in this case is square root of x, okay? So I wrote that here. This is nothing, sorry. Then here's my integral, and again, I use my calculator. You get 1/6 pi or 0.1667 pi.
For time.